we talked about how inheritance creates an ancestry for our objects. To check for this ancestry, we can use the is-a rule. An apple is a fruit. A piglet is an animal. They inherit the attributes and methods of their parent class, and so they allow us to reduce code duplication. But what if you have a relationship between classes where one class isn't a child of the other? Sounds confusing? Let's check out an example to get a better idea of this. Say we have a package class that represents a software package which could be installed on every machine on our network. This class has a lot of information on the software, like the name, the version, the size, and more. We also have a repository class that represents all the packages that we have available for installation internally. In this class, we want to know how many packages there are and what's the total size of all the packages. In this case, the repository isn't a package and the package isn't a repository. Instead, the repository contains packages. To model this within our code, the repository class will have an attribute that could be a list or a dictionary, which will contain instances of the package class. So for this scenario, we'll make use of the code in the other classes by calling their methods. This is what's called composition. Let's see this in action. We'll first create a repository class that starts with an empty dictionary of packages when it's created. The dictionary will have the names of the packages as keys and the package objects as values. Nice. We have our class, which starts with an empty dictionary of packages. You might be wondering why we're adding the dictionary in the constructor instead of directly to the class. The answer to this might be a bit tricky to understand, so let's go back to our Juicy Apple example to help make sure this is clear. We defined earlier a class called Apple and set some basic attributes for it, like color and flavor. All instances of the Apple class will be initialized with the values that we preset for those attributes. If we change the color of one apple from red to golden, we substitute the old value with the new one. And super important to remember, this action happens only for that particular instance. But what if, ew, this apple has a worm in it? What if we wanted our Apple class to also have a list of worms? If we created the list when constructing the class, then all instances of the Apple class would have the same exact list. So if we added a worm to the list, it would get added to the one list that's shared by all instances. To avoid this, we need to create the list at the time of creating the instance instead of when creating the class. By doing this, each instance will have its own list independent of the others. This happens with all attributes that are mutable. Because when we modify a mutable attribute, we're not replacing a value with another, we're changing the contents of the original attribute. In our repository case, the packages attribute is a dictionary, which is mutable. We'll be modifying its contents by adding and removing elements in it. If we created it at the class level, all instances of the repository class would use the same dictionary, and items added or removed would affect all instances at the same time. If that's still a bit confusing, don't worry, I was also confused the first time I came across it. Just take your time, rewatch this video if you need, and remember this rule of thumb. Always initialize mutable attributes in the constructor. So great, we've got our dictionary, but how will we add packages to it? We'll create an add package method. Now we can add packages to the dictionary. We could also write a similar method to remove the packages, but I bet you can work that out without my help. Let's do something more interesting instead. We said that the packages had a size attribute that holds the size in bytes that the software package requires. So, how could we calculate the size of the whole repository? We'd need to iterate over the packages contained in the dictionary, adding up all their sizes. I'd go something like this. We're going to add up all the sizes. So the first thing we need to do is create a result variable that we'll use to sum up the values. Awesome. We have our result initialized. We now need to go through all the packages in the dictionary. Remember, the keys are the package names and the values are the package objects. For our calculation, we only care about the objects, so we'll retrieve them with the values dictionary method. And now, for each package, we want to add the size to the result variable. Nice. We're almost done. We just need to return the result now. Take a look at the method we've just written. It's a method inside the repository class that's making use of the values method in the dictionary class, and it's accessing the size attribute in the package class. That is the power of composition. When we have other objects as attributes, we can use all their attributes and methods to get our own code to do what we want. Wow, that was pretty complex, huh? Chances are you won't get it the first time around. Most of us don't. So if you're worried you might have missed something, take your time to review the contents. We want you to feel confident before moving on. When you're ready, meet me in the next video, where we're going to talk about a different kind of code reuse, using Python modules.